All right, hey everyone. Today was day 14 of Advent of Code, and today was quite an interesting puzzle. I quite enjoyed it, so let's have a look into it. So what we're given today is a platform, and it has three different entities on it. So there is those round rocks that can roll around. There's the square rocks, which are fixed in place, and there's empty space. What we do for the first part is we tilt the platform north so that every rolling rocks roll to the north direction. And then that will end up looking something like this. So each round rock moves north as long as until it hits another object. So that could either be a square rock or the edge of the platform, or another round rock that came to a halt. And then what we need to calculate is just the total load. So the total load for each round rock in the first line, in the lowest line, will be 1, and then 2, and 3, and so on. And we just sum it over all the round rocks. Okay, so how can we do that? So we'll define an enum to make our lives a bit easier, that we have that has put the three options of an empty rock, a round rock, and a square rock. And then we will, as usual, have positions as tuples of two integers, and the platform will be a dictionary from a position to an entity. Then we can parse the lines as usual, but just going through all the lines in each line and filling a platform dictionary. And then what we will need to do in order to solve the problem is tilt a platform north. For that, we can just tilt each individual column north separately. So how can we tilt the column north? So we'll keep track of the next empty y coordinate, and it starts at 0, and then we go for the current y, and it also starts at 0 at the topmost element. And then we consider the object at the current position. So if the object is a square rock, then we don't have to do anything, nothing is moving, but the next empty y coordinate will be the current y plus 1, so the next after the rock. And then we continue. The other option is if the entity is a round rock, then it actually is rolling, so we need to do some updates. So in particular, the platform as the current, so we take the rock from the platform at the current position, so we set it to empty, and we place the rock at the next empty y position. So importantly, we need to do first this line, because the current y and the next empty y might be the same, so we need to first remove it and then add it in order to not let a rock vanish. And then we update the next y, next empty y to the next position. And if the object is empty space, then we don't need to do anything. Okay, so that allows us to solve the problem essentially. We only need to calculate the total load as well. So for that, we just go through all the different positions and we consider the object at the position. If it's a round rock, then that will contribute to the total load. Otherwise it doesn't. And then the rock load will just given by this formula. So we take the y coordinate and subtract it from the max y, and then we need to add 1. And we sum all those rock loads up into one total load, and that will give us the solution to the problem. So let's try this on the test input. That looks good. So we also run it on the real input, and it also gives us the right solution. For part 2, things becomes more interesting and a bit more complicated. So we don't only tilt north, but this time we tilt in all directions, north, west, and so on. And then one cycle of tilting in all 4 directions. We're not only doing one of them, but actually like a very large number of them, of those cycles. So yes, that will, and we again supposed to be calculating the total load at the end of this whole process. So for that, what we can do, we could implement all the tilt north, tilt south, tilt west functions, but instead, to make life a bit easier, we instead consider rotating the platform instead of tilting in different directions and always tilting north. So in order to rotate the platform, we have a function that maps, like, for example, the position 0, 0 will then be max y and 0, 0, 1 will be max y minus 1, 0, and so on. So the function, we just define a new dictionary and essentially convert the key xy to the key y minus, or max y minus y and x, and that will be a new dictionary that corresponds to a rotated platform. And then in order to apply a circle, we just tilt north, then we rotate the platform, then we tilt north, then we rotate the platform, and so on. Yes, that will allow us to apply one cycle. We need to apply a very, very large number of them. So how can we be a bit smart of them? So what we want to do is find some periodicity, so that we find a position that we've already seen. So for that, we of course first parse the lines, and then we keep a dictionary that essentially maps a platform, a particular platform, to an integer when it appeared the last time or the previous appearance. And then we start with iteration 0, and then we do something while the iteration is smaller than this very large number of cycles. And then first we apply the cycle to the platform to get a new platform. And then, because that's a dictionary, we want to use the platform as a key in a dictionary. So we need to convert it to some immutable object. So what we can use is this: get the items of the platform dictionary and convert that into a frozen set. Okay, and then we check if the platform key is in the previous appearances. So we already seen the same platform. That's nice. We can do a little shortcut there. So the previous iteration will be given by the dictionary, and then we can calculate the iteration difference. And then what we can do is update the iteration. So for example, we can add the iteration difference once or twice or 3 times or so on. It does not make a difference because this amount of iteration always leaves us with the same platform. So in order to edit a lot of times at the same time, essentially we consider the number of iteration that is left. And then we just subtract the iteration difference as often as possible from this number. So the new iteration that's equal to just using the modulo operator. So the new number of iterations left will be the iterations left modulo this iteration difference. And then we set the iteration to represent the new iterations left, but just said adding it to the number of cycles minus the new iterations left. And then, yeah, that will update the iteration number to a very high number, and then hopefully we're done soon. And in each iteration, no matter whether we had the platform key already or not, we essentially add the platform key to this dictionary, and we increment the iteration as well. So that's the function to iterate the number of cycles time with a big shortcut jump in the middle here. And in the end, we just need to get the total load of the final platform in order to get our solution. Okay, so we should run a test on the test input. That seems to work out well. So here, for example, it finds iteration 2 and 9 already equal. So it jumps forward from iteration 9 to iteration with this number. So there's quite a big jump. Of course, it couldn't do it by calculating each iteration manually. If you run it on a real input, that takes a bit more than a minute, so there's probably smarter solutions out there, but it works and it gives us the right solution. All right, that was it for day 14. I hope you enjoyed today's puzzle. I definitely did, and see you around.